Good morning. Your I can statement for today is I can add mixed numbers. And if you'll remember from last time we took notes, mixed numbers are numbers that have a whole number and a fraction put together. So in this problem, 1 and 1/2 would be a mixed number, and 2 and 2/3 would be a mixed number. Both of those are mixed numbers, and today we're going to learn how to add mixed numbers together. So there's approximately three steps that you need to take when you're adding mixed numbers together. So let's first start by reading the problem. Rhonda mixes 1.5 cups of sand with 2 2/3 cups of potting mixture to prepare soil for her cactus plants. After mixing them together, how many cups of soil does Rhonda have? Okay, let's circle our key words. Our key numbers. 1.5, 2 2/3. Underline the question. How many cups of soil does Rhonda have? Box any keywords. I would say cups is a keyword. Together is a keyword. That tells us that she's putting two things together, not taking them apart. So together probably means that we're adding. If you said adding, you are correct. And then we're going to eliminate anything we don't need. Bye, Rhonda. We're glad that she has a cactus, but we don't really care. And then we're going to solve. So using our cubing strategy, we figured out that she's putting two things together. She's putting sand and potting mixture together. Okay? Putting things together tells me that we're going to add, right? Because I'm not taking anything away. So let's start by writing our key numbers down here. We have 1 and 1/2. And I know I need to add. That's 1 and 1/2 cups of sand right here. And I know I'm putting them together, so I'm adding the 2 and 2/3 cups of planting mixture. Okay? So the very first step that you need to take, like I said, there's approximately 3 steps when you're adding mixed numbers. And if you find a different way to do this that works for you, that's great. But this is kind of the standard way to do it. So step 1, I'm just going to label that here, is to find a common denominator for your fraction, which we all know how to do. We've been doing this for quite some time. We all know how to find a common denominator. Okay, so my whole numbers in this case are 1 is a whole number. Okay, that's not my fraction. And 2 is my whole number. My fractions are 1/2 and 2/3. So I'm going to rewrite those down here. 1/2 and 2/3. Now, if I'm finding a common denominator for my fraction, we know how to do this. I look at my denominators and say, okay, well, do I need to use my least common multiple? Can I multiply across? Is there a factor for one of my denominators? And in this case, I would say that multiplying or using the least common multiple is going to get you your common denominator. So 2 and 3, what they have in common is 6. So in order to get 6 in my denominator, I need to multiply by 3, and whatever I do to my denominator, I have to do to my numerator. My new equivalent fraction is then 3/6. And then I need to get 6 in this denominator, so I multiply, that shouldn't be an equal sign, I'm sorry, I multiply by 2, and whatever I do to the denominator, I have to do to the numerator. 2 times 2 is 4, 3 times 2 is 6. So now I have 2 new equivalent fractions that have the same denominator in them. Okay, so now I'm going to rewrite my problem. Remember, I had 1 here from my original problem, and we said that 1/2 is also equal to 3/6. So 1 and 3/6 plus 2 from my original problem, and I made an equivalent fraction from 2/3 into 4/6, plus 2 and 4/6. So now here is my new problem. I have 1 and 3/6 plus 2 and 4/6, and I have a common denominator of 6 on the bottom. So now what I'm doing is simply adding the fractions together. So that's my step 2. Step 2, add your fractions together. And this part kind of has 2 steps, which is why I said it's kind of 3 steps, but you'll see what I mean in a second. So I'm going to add my fractions together. So my whole numbers, I have 1 plus 2. My whole numbers all underlined so you can see what I'm doing. 1 plus 2. I'm going to write that here. 1 plus 2 gives me, hopefully you said 3. And then I'm going to add my fractions like I normally would. 3/6 plus 4/6. So I'm going to write that down here. 3, whoa, you can't see that at all. Sorry. Switch pen colors. 3/6 plus 4/6. And we know that we just leave the denominator alone. That just stays the same. I get 6 on the bottom, but I add my numerators. 4 plus 3, or 3 plus 4, is 7. So then I put my whole number and my fraction together for a final answer of 3 7/6. Now, this is technically correct. This is done. I added my whole numbers and my fractions together to get 3 7/6. However, this 7/6 right here, I'm going to highlight it. This 7/6 is what we call an improper fraction. Okay, I'm going to label it. This is an improper fraction because the numerator is bigger than the denominator. That's what an improper fraction means. So when you see something like this with an improper fraction, you want to convert it, change it, and make it so that it's a mixed number again. Because right now we have a mixed number and an improper fraction, and we just want a mixed number in the end. So step 3 is going to be convert your, or just make sure, maybe we'll say, make sure to have a complete mixed number with no improper fractions. And remember, an improper fraction just means that my numerator is bigger than my denominator. And you can see that here, that 7 is bigger than 6. So the way that I fix that is I take a look at my numerator and my denominator and I say, okay, well, how many times can 6, my denominator, go into 7? Because 6 is my whole number, right? So I want to say, how many times can my denominator go into my numerator without going over? Well, we know that 6, my whole number, can go into 7 one time without going over, right? So that's my whole number. Okay, I'm going to circle this so that you can kind of see what I'm doing. So 6, my denominator, can go into my numerator one time without going over, right? So I have a 1 right here. This 1 is a whole. It's a whole number, right? 6/6 equals 1. So this 1 gets added to my whole number that's already on the outside. So 3 plus 1, I'm adding a whole from my denominator, equals 4. That's my new whole number. Then I have to ask myself, okay, well, 6 can go into 7 one time, yes, but there is still 1 left over, right? There's still 1 left over because 7 minus 6 gives us 1. And here you can see this 1 over 6 that's left over. And that's how I change an improper fraction back into a mixed number. I took my denominator and said, okay, well, how many times can it go into my numerator without going over? It can go in 1 whole time, which I add to my whole number here, and that's how I got 4. And then I have a remaining 1/6 left over because it doesn't go into 7 equally. I have 1/6 left over, which is my new and final answer. 4 1/6 cups of soil is what she will need. 4 1/6 cups. Okay? So like I said, it's a 3-step process. You find your common denominator first, add your fractions together, so your whole numbers, then your fractions. And then, if necessary, turn your improper fractions into a mixed number with no improper fraction.